Hello, hello students. Today we are discuss about the another topic types of single phase induction motor, the methods of starting, how we start the this machine. So first, in the single phase induction motor are not the self starting we have studied in a previous lecture. Now we will talk about the single phase induction motor is not the self started we understand in the previous lecture. Today we discuss about the how and which are the different motors available for the single phase induction motor. So first we will study the split phase induction motor. So split phase induction motor is nothing but we are splitting the one phase. Actually this is the single phase induction motor, but in this single phase induction motor is not enough to start our machine to rotate. That's why we are just splitting the one phase in two different parts. So one single stator, now we have the two windings. Main winding, either it's called a running winding, and another winding is called the auxiliary winding or the starting winding. So two windings are spaced a 90-degree electrical apart and are connected in parallel across the one phase AC supply. See the single line diagram and the phasor diagram of it. This theory, split phase induction motor. In the split phase induction motor, the main winding has the low resistance and high reactance, and the starting winding itself has the high resistance and low reactance. This is the base of this theory. Just see this single line diagram. So in this single line diagram, we have to see that the starting winding is active during the starting of the motor and is disconnected from the supply when the motor picks up the speed above 70 to 80% of the rated speed, and that's why we have to put the centrifugal switch. The centrifugal switch is used to disconnect the starting winding automatically when the motor picks up to the speed about to 70 to 80% of the rated full load. Hence, under the normal running condition, only the main winding is active. The resistance of the starting or auxiliary winding can be increased by two ways. Either high resistance R may be connected in series with the starting winding, or by using high resistance copper wire for the starting winding. At the starting both the windings draw a current from the supply. As the main winding has the low resistance and high reactance, the current drawn by the main winding IM lags the applied voltage and greater angle phi m. Just see the phasor diagram. The angle with respect to the voltage, it is phi m. It is the higher angles compared to the theta s. Whereas the current drawn by the starting winding IS lags the applied voltage by a small angle theta s, as it has the high resistance and low reactance. That's why just see the difference between these two angles, theta s and theta n. Finally, for the starting of the induction motor, we are mainly focused on the alpha, the angle between these two current. If this maximum, in a previous lecture we talked about the maximum angle is the 90 degree. So when you achieve the 90 degree, then it's called the highest torque you will get in that situation. But in this situation, this is not the 90 degree because it's a split phase. So that's why we have the alpha. The phase shift between IM and IS should be as large as possible, so the starting torque of this motor is proportional to sine alpha, where alpha is the split. In a well-designed split phase induction motor, the phase shift angle between two current IM and IS may be high as a 60 degree. In the split phase, you will achieve up to maximum 60 degree. The resultant of this two current produce a rotating magnetic field and hence make the motor self-starting. As the two current IM and IS are splitted from each other by an angle alpha at the start, this motor is called the split phase induction motor. This is the reason, that's why it is called the split phase induction motor. Okay, this is the theory. Now we talk about the another type of the motor, that's called capacitor type single phase induction motor. Capacitor type single phase induction motor So capacitors type single phase induction motor itself have the three different another part, three different types of the motor available for the capacitor type single phase induction motor. We have seen in this our daily routine life. We have seen our fan itself have the capacitor. That's why it's called capacitor start, capacitor run induction motor. So now capacitor start motor, two value capacitor motors are also available. In this motors, our capacitor is connected in series with the starting or the auxiliary winding. Actually, our main objective is that, because we know that we have the two fluxes, both the fluxes are equal in opposite direction. So we just reduce either one flux. If we are reducing a one flux, then automatically it will rotate. So that a small objective which is fulfilled with this idea. So that's why we put the capacitor here. And if you put the capacitor across the machine, across the stator, that means we are improving the power factor of the machine also. That's why it's good. Otherwise people think about the inductor also, but we know that the inductor, if we use the inductor, so the machine performance is poor as compared to the capacitor. That's why. So the capacitor start motor, just see the single phase diagram and the phasor diagram of capacitor start motor. Here we use a switch, that is a centrifugal switch, and you all people know that what is the use of centrifugal switch. After we achieve the 70 to 80% of the full load speed, then this centrifugal switch is disconnect the capacitor. It is not the permanent capacitor start motor, it is the capacitor start motor. So the construction is similar to the split phase type induction motor. You have seen this. Only difference is that construction capacitor is connected in series with the starting and auxiliary winding, which takes the leading current. The current drawn by the main winding IM leads the applied by theta m, whereas the current drawn by the starting winding leads the applied voltage by theta s due to the capacitor. Hence, the phase angle between the two current IM and IS is increased almost 90 degree as shown in the phasor diagram. Thus, higher starting torque can be obtained with the capacitor start induction motor. When the motor obtains the speed close to the full load speed, the starting winding and the capacitor are disconnected from the supply by the centrifugal switch. Hence, under the normal running condition, the motor operated with only the main winding. The capacitor remains in the circuit only at start. Hence, the motor is called capacitor start motor. That means here we have to achieve the higher torque and all the benefits because of the capacitor is not used in a long time, because it is the disconnected after the load would be increased. So now another second type of the motor, we understand the second type of the motor, that motor is called the permanent capacitor motor. Permanent capacitor motor is nothing but it's a, now we just add a permanently capacitor. In this motor there is a no centrifugal switch is connected, so it is a look like a capacitor motor only. So the power factor and the under the running condition is very high. Okay, power factor of the running condition is very high as compared to the capacitor start motor, because here we put the permanently capacitor. The power factor of this motor under the running is high. The operation is also quite and smooth. The phasor diagram is both the motor has the same phasor diagram. Okay, so you should not confuse about the phasor diagram. I have not drawn the separately phasor diagram, so you should draw this phasor diagram permanently. The torque under the running condition is higher than capacitor start split phase type motor. It has the better efficiency and improve the performance over the capacitor start motor. Now we have to discuss about the last type of the motor which is used in the single phase type of the motor, that is a two value capacitor motor. So in the two value capacitor motor, we have used the two separate capacitor. One is capacitor is used for the starting and another one is used for the improving the efficiency, improving the motor performance. This type of motor employs has the two capacitor, start capacitor CS and run capacitor CR. The start capacitor CS is rated for a short time rating and is used for starting. The second or running capacitor CR is rated or continuously, so used under the running condition. The centrifugal switch is used to disconnect the start capacitor when the motor has reached 70 to 80% of its full load speed. Hence, by using the two capacitors, the performance of the motor improves both the time of a starting under the running. This motor is useful where the motor has to start against the heavy load. The starting torque is about 2 to 2.5 times its full load torque. It has the advantages of the quiet operation, smooth running, and high efficiency and high starting torque. There are a lot of advantages as compared to the other type of the motor. So this is the all theory related to the single phase induction motor. Thank you. Thank you.